Hello everyone. Today we're going to continue with the other videos, the other questions from June 2021. So you can practice for September and end of the year. So we're going to go on. Last video we did question 2. Question 1 we're going to do it for last because it's everything related. So we're going to go to answer all the other questions and then we're going to go back to question 1. Last video we did question 2. Now we're going to do question 3. Now, once more, I recommend you to try and answer question 3 before you watch the video. It will help. So use the video for the solution. Use the video for the solution. You did the topic. You know how to answer the question. Only just use the video to mark the question. Okay? So now this question is about projectile. Alright, projectile is not a difficult topic. However, sometimes learners struggle with it. Okay, so let's go on to this question. Question 3 states, a ball is thrown vertically upward. It leaves the thrower's hand with a speed of 15 meters per second. Now, that speed with which the ball is moving upward, so the velocity of the ball will be 15 meters per second upward, and there is not friction. Okay, explain what it means by projectile. So let's before we do the drawing and the sketch of the situation, let's answer question 3.1, which is a definition. What is a projectile? Right? So solution 3.1, projectile. Now, what is projectile? Projectile is an object. It's an object that moves under the influence let's make this word, under the influence of gravitational force only. Now, why did I highlight that one? It's an object. First of all, projectile is an object that obvious, the object is moving under the influence of gravitational force. Now, only is very, very important. If you don't write only, you won't get the mark. Okay? Now, this question will have 2 marks for the definition, and obvious note, the 2 marks are allocated according to this specific important word. It's objects that move under the influence of gravitational force only. If the word only is missing, then you don't get the 2 marks. Okay? So please be careful with the definition. It's very, very important. It's also very easy to get confused with the projectile motion or free fall. Right? It's very easy to get confused. What is the difference? Projectile is an object. Free fall is a motion of an object. Right? So be careful with that one, but eventually we'll do some questions on projectile. Okay? Now, 3.2. 3.2 say, what is the acceleration of the ball at its maximum height? Now, before we do that one, let's sketch the situation. We have a ball that is being thrown upward. I'm going to count the hand of the thrower as the reference point, at the 0 position, okay? The initial position of the ball. This ball is going to move up a certain height, and then obviously it's going to return to the starting point. Okay? Now, the velocity here of the object, which is the initial one, is 15 meters per second. Okay? Now, the velocity when the object is at its maximum height, the velocity is going to be equal to 0 meters per second. Now, this is important to know. Now, there's another important thing to know here before we answer this question. The velocity of the object is going to be the same, but in opposite direction in different positions. For example, if the object is being thrown upward with a velocity or speed of 15 meters per second, when that object is at the same position, the magnitude of the velocity is going to be the same. It's going to be the same, but in opposite direction. That means that here, in this specific position, the velocity of the object is also going to be 15 meters per second, but down. Okay, but we're going to go to that explanation now. Let's do an arrow here, so you know this one is going up, this one is going down. Now, what is the other important thing? The time to go up to the maximum height is equal to the time to come down. So time to go up is equal to time to come down. Now, important to know, this is happening if the object is moving uninterrupted. If there is a ceiling here and the object hit the ceiling, then obviously this you cannot consider this one because this is an interruption in the motion. This is when the object moves freely without interruption. Okay, so the time to go up is equal to the time to go down. And the acceleration of the object, look here what you said. You said in the definition that move under the influence of gravitational force only. So the only force acting is gravitational force. Therefore, the acceleration is equal to the acceleration due to gravity, and it's always going to be 9.8 meters per second square down. Now, I didn't write up yet because there is an important thing that we're going to consider in this question. Remember, when we're working with this problem, you have to select direction as positive or negative. Okay, so we're going to say that up is positive, but this is up to you. You can also say down is positive, and then you will get exactly the same answer. But now this one is very, very, very important. All right, now we're going back to all the numbers we wrote here, all the data, and we say initial velocity is up, therefore it's going to be positive. Here, the velocity at the same point of the initial is going to be negative because it's down. Time is a scalar quantity, so you don't consider the direction. And the acceleration is downward all the time, and I said up is positive, therefore this one is going to be negative. Right? This is the case for further question, but however, we can answer now the question 3.2. What is, let's go to the question so you can see. The question said, what is the acceleration of the ball at its maximum height? The acceleration is always going to be 9.8. The acceleration, which is equal to g, is going to be equal to 9.8 meters per second square down. Now, it is actually to the center, towards the center of the earth, but you can write down and it will be fine. So this is the answer. You get in this specific question 1 mark for that one, and you only get a mark if you did write the word down. Otherwise, you don't get the mark. So the correct answer is 9.8 meters per second downwards, and that is 1 mark for that specific question. Okay, I hope that is clear. If you want more about this situation, you can write a comment and I will answer you. Okay, now let's go to question 3.3. Now remember, we are going to consider, and I'm going to rewrite it up as positive for the entire question. Up positive, and this is going to be for the entire question. Now there's many options that we can use to solve this question. This question says calculate the time taken by the ball to return to the level ground. So it's the time the ball takes to go to the maximum height from starting position to maximum height, and then coming back from maximum height to starting position. Okay, there are different options. I'm going to just explain 2 options, but there are many. There are many options. Okay. Option 1. Now in option 1, as I said, let's quickly go here and look at the formulas we have. Now, what formulas can we use for this type of motion? The acceleration due to gravity is here in the constant. You can see there, right? The first constant you have in this table of constant is acceleration due to gravity. Okay, please don't make a mistake. It's a very easy one, and you will need it all the time. Now here, when you go to the formulas, this first table you have there is the one that is going to help you in the questions on projectile. So I recommend you to come always to the formula so you don't make mistakes. Okay, now if you note all the formulas, we have a couple of formulas here. The first one is the one that is going to help us. Why? Because we have all the data. We have the final velocity, we have the initial velocity, we have the acceleration, and we are looking for them. In all the other equations, you see you have displacement. Right, there is delta x, here is delta x, and you don't have displacement. Now, note, displacement, distance cover can be calculated, but it will be double work. So here we don't have to calculate extra things. So let's start by saying the final velocity is equal to the initial velocity plus the acceleration multiplied by the time. If you want, you here by acceleration can write g already. Sorry, I prefer to write g. Now, we're going to take from starting to ending point. So what is the final velocity of the object which reaches the thrower hand? Is still 15 meters per second, but down. So it will be negative minus 15 meters per second. What is the initial velocity of the ball? Is 15 meters per second up. I said up is positive, therefore is positive 15. Plus 9,8, which is the acceleration, but I said up is positive, so it's minus 9,8 because 9,8 is always downward, multiplied by the time. Alright, so if you rearrange this, you have minus 15 divided by minus 9,8 is equal to the time. Alright, so we can do the calculation quickly. Let me just clear the history, and here, so we have minus 15 is minus 30. So it's 30 divided by 9,8. Remember minus divided by minus is positive, okay? So the answer is 3,06 seconds. 3,06 seconds. This is one of the options. Now, if you use this option, the mark allocation will be 1 for the formula, 1 for the substitution. Now, if you perhaps said down is positive, then obviously this one will be a positive, this one will be negative, and this one will be positive, okay? But we are going to continue with our way. All this one carries 1 mark. Now note, if you make a mistake with any of the sign, you lose the mark. So please do not make mistake with the sign. That's why I recommend always to start by doing this, writing that one, and then coming back to the drawing and start writing all the data with its sign. Okay, so this is one option. Let's revise another option. Option 2 now. In option 2, we are going to consider only the option up as moving up. Now, as moving up, what do we have? And we are going to redraw here quickly. As in moving up, we have the initial velocity equal to positive 15 meters per second. And then the ball will stop eventually at maximum height. This is maximum, v is equal to 0. So we're going to calculate the time to go up. And now remember, time, total time is equal to time to go up plus time to come down. But time to go up is equal to the time to come down. Alright? So we're going to use or make use of this one. We're going to calculate only the time to go up, and then we multiply by 2. Okay? Same formula. We don't have to change the formula. We have that the final velocity is equal to the initial velocity plus acceleration multiplied by time. The final velocity, now we're talking about the maximum height. So the final velocity is going to be 0. Okay, so this one is 0 is equal to the initial, which is 15 positive because it's up, plus minus 9,8 multiplied by the time. When you rearrange this one, you get minus 15 divided by minus 9,8 is going to be positive answer. This is the time, which is equal to, if we use my calculator, is 15 divided by 9,8 is 1,5306. So we're going to round off to 2 decimal places. Is 1,53 to 1,53. Now this is not the answer. This is the time to go up. Sorry, let me just write this is the time to go up. Is equal to the time to come down, and that is equal to, let me just move this one a little bit to the left. There we go. This is equal to 1,56 seconds, but this is not what I want. I want the total time. So the total time will be 1,56 is 1,56, 1,53, sorry. Let's fix the number, otherwise we'll get a different answer. 1,53. I'm sorry about that. 1,53 times 2. Alright? Because it's the same time to go up and down. So I'm going to leave it there. Times 2, 3,06. So the answer is 3,06 seconds. You can see it's the same one as the previous question. If you use this method, it's a little bit longer because you just have to multiply by 2 at the end. The marks allocation are 1 for the formula, 1 for the entire substitution. Be careful, the minus must be there. If that minus is not there, then you lose all the marks, and then the final answer. So those are the 3 marks for this question. Okay? Right. So that is 3.3. Now let's go to 3.4. There's more options. Remember I said there's more options to solve this question, but I think those 2 are good enough for now. You can practice the other ones and compare the answer, and you can always write the comment. You can write comment. You can ask me if you want any question. Okay. Now the other one, question 3.4, is to draw a graph. 3.4. Now in this question, let's see what is the question asking and what do they want us to draw in the graph. Alright, this question says, draw the velocity times graph for the motion of the ball from the moment it is thrown upward until it returns to the point at which it was thrown. Show the following, and they want some data in your graph. This must be in your graph, otherwise you don't get marked. They want the initial velocity of the ball, the final velocity, time taken for the ball to reach the maximum height, and the time taken by the ball to return to the starting point. Okay, all the data was calculated, so it should not be a big problem. Now, the axis. This is the y-axis, which is velocity in meters per second. This is important, everyone. Please make sure you draw the heading of the axis. This is the x-axis, which will be coming for time. Remember, even for the graph, we are going to consider up as positive. But you can also set down is positive, and then obviously the graph will change just a little bit. Now, this is 0. Remember, the origin of the graph is 0. What is the initial velocity of the ball? It is 15. Positive because we said up is positive. So 15 meters per second. How long does that ball take to reach the maximum height? At maximum height, the velocity is 0. How long it takes? It takes 1,53. 1,53 seconds. Now note, if you didn't answer using this option, all you have to do is to get the 3,06 and divide by 2, because it's equal time to go up as time to go down. So this is the first part of the graph, a straight line from 15 to 1,3. Alright, now what is happening there? The object of the ball changed direction with the same acceleration, so the gradient is the same. You cannot now change the gradient, right? So what is the final velocity of the ball, is going to be 15 meters per second, but downward. Therefore, it's negative. Look here, our drawing. Initial is positive 15, final is negative 15, right? So it's negative 15. How long it take for that ball to reach negative 15? Okay, 1,53 times 1,53, times 2 is double, is equal to 3,06. That is the final time. Right? Let's write the same color, 3,06 seconds. And then the graph is going all the way a straight line from that one to that point. So this is the graph that they want. I'm going to explain quickly again. The starting or the initial velocity of the block is 15 meters per second. That ball takes 1,53 seconds to reach the maximum height in which the velocity is 0. Alright? Now, the ball changed direction and just arrived to the hand of the thrower with a velocity equal to the initial velocity, which is 15 meters per second, but in the opposite direction. What is the total time taken to do that? 3,06. Now, the marks allocation here are 1 mark for the shape. Shape means it must be in a straight line, as it is there. 1 mark for saying initial velocity, for showing in the graph, equal to positive 15 meters per second, and final velocity is equal to negative 15 meters per second. That is the second mark for both. You get 1 mark for both. You get 1 mark. I'm going to write it here at the bottom. 1 mark for time to go up, which is equal to 1,53 seconds, and then you get 1 mark for total time, which is equal to 3,06 seconds. There is 4 marks for this drawing of the graph or sketching of the graph. There is the question 3, the total mark of the whole question. Let me just write it with other color so you can see it. The total of the whole question is 10 marks, right? 10 marks. There you get 2 marks for the definition of projectile. This definition is always all the time in the examination, either projectile or free fall. There is 1 mark for staying or saying that the acceleration is 9,8 downwards. It's 1 mark for that one. There is 3 marks for the calculation of the total time, and then is 4 marks for the drawing of the graph. Thank you very much. I hope it helped. If you have any question, you can write a comment. You can ask me. I will be pleased to answer you. Thank you very much. Next time we're going to go to question 4, which is work energy and power. We did a lot of video on that one, but we're going to solve the question. Okay. Thank you very much. See you next time.